Hi everyone, today we're going to be talking about dividing rational numbers. There are two phrases I want you guys to remember whenever we're talking about dividing fractions. So, dividing fractions ain't no test, inverse the second, and multiply the rest. The second one is KCF, which stands for keep, change, flip. Both of these are saying the same thing, just a little bit in different ways. So whichever one is easy for you to remember, I want you to keep that in mind whenever we're dividing fractions. So for example, if I had 1/4 divided by 1/3, dividing fractions ain't no test, inverse the second. So inverse means to flip or do the reciprocal. So instead of 1/3, I would have 3/1, and then multiply the rest. And that's exactly what keep, change, flip is saying, because as you can see, you keep the first fraction the same, you change division to multiplication, and you flip the second fraction. So now that we know those, let's go into some examples. So example 1, this water tank is losing 3 3/5 gallons, and since it's losing, we have a negative there, in 6 minutes. We want to figure out what the change is just after 1 minute. So to figure out that change, we are going to divide. So we have negative 3 3/5 divided by 6. Now there are two ways that we can actually solve these out. So the first way would be to turn our fraction into a decimal. To do that, this negative 3, this is our whole number. So I'm going to pull that out right away. My 3/5. How do I turn a fraction into a decimal? I divide. So I'm going to put 5 on the outside of my division house because the denominator always goes on the outside, and 3 on the inside. Can 5 go into 3? No, it cannot, so I need to add a decimal and a 0. 5 can go into 30. It can go in 6 times. 5 times 6 is actually 30, so there is nothing left over. So now I can just tack on my 0.6 to my negative 3. So now my expression reads negative 3.6 divided by 6. And now what I can do is set that up in my division house. So what I'm dividing by always goes on the outside. I'm going to leave out the negative just right now, just to keep my division house clean. I'm going to bring my decimal up. 6 can go into 36. How many times? 6 times. So my answer here would be negative 0.6. You can also just put negative 0.6. The second way to solve this out would be to keep them as fractions. So what is 6 as a fraction? 6 as a fraction is 6/1 because any whole number as a fraction is over 1. I would then need to turn my mixed number into an improper fraction. To do that, I multiply my denominator by my whole number and add my numerator. So 3 times 5 is 15, plus my numerator, which is 3, which is 18. I want to make sure I keep that negative sign. And your denominator always stays the same, which is 5. Now I can do whichever saying makes the most sense to you, whether that's keep, change, flip, or whether that's dividing fractions ain't no test, inverse the second. So instead of 6/1, I'm going to have 1/6 and multiply the rest. Now what you can do is multiply straight across, top times top, bottom times bottom. Negative 18 times 1 is negative 18. 5 times 6 is 30. This is not in simplest form, so I want to go ahead and simplify that. 18 and 30 are both divisible by what? They are both divisible by 3. 18 divided by 3 is what? 6. 30 divided by 3 is 10. And I can go ahead and simplify even further because I can divide both of these numbers by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. Make sure I keep my denominator. And we've already done 3 divided by 5. We know that's 0.6. So there are 2 ways to solve our division problems with rational numbers. So you can either turn it into decimals or turn them into fractions, whichever makes the most sense to you. Let's try another one. Example 2, negative 0.4 divided by 0.25. So the first way you could do this is turn them into fractions. Negative 0.4 would be negative 4 over 10 because my 4 is in the tens place. Divided by what is 0.25 as a fraction? 25 over 100. Then we can just use our keep, change, flip, or inverse the second, multiply the rest to solve that out. The other way that we can do this is by moving our decimal placing over. So whenever you are dividing with decimals, you can never have a decimal when you are dividing in your division house. You can never have a decimal on the outside. So what you're dividing by cannot have a decimal. So that means that we need to move our decimal placing over to turn this into a whole number. So there are 2 digits to the right of my decimal place. So what I'm going to do is move my decimal place over 2 times. 1, 2. This is the same as multiplying by 100. And whatever I do to one side, I have to do to the other. So 0.25 would turn into 25. 0.4, 1, 2 would turn into negative 40. And now that I have my whole numbers, I can go ahead and set this up inside my division house. So what I'm dividing by goes on the outside, 40 goes on the inside. 25 can go into 40 how many times? 25 can go into 40 one time. 25 times 1 is 25. To subtract here, I'm going to have to borrow from my 4. 10 minus 5 is 5. 3 minus 2 is 1. Can 25 go into 15? No, it cannot. So I need to add or annex a 0 and a decimal. And now I have how many times can 25 go into 150? Which is 6 times. 25 times 6 is actually 150. So my answer here is 1.6, but I'm dividing a negative and a positive. So is my answer going to be negative or positive? It's going to be negative. So negative 1.6. Last one, example 3, 0.7 divided by negative 1 and 1/6. So I'm going to go ahead and turn my decimal into a fraction this time. What is 0.7 as a fraction? 7 over 10. I'm next going to turn my mixed number into an improper fraction. Just as a reminder, I'm going to multiply and then add my numerator. So what would this turn into as an improper fraction? Well, 1 times 6 is 6. Plus my 1 is 7, so I'm going to have negative 7 over 6. So I need to inverse my second, negative 6 over 7, multiply the rest. Now, I could just go ahead and multiply straight across, top times top, bottom times bottom, but this time around, I'm going to show you guys a different way. Let's simplify before we multiply. To do that, I am going to look at opposites or diagonals. Now, looking at 7 and 7, what could I divide both 7 and 7 by to simplify? I could divide both of these by 7. When I do that, 7 divided by 7 is 1. So my numerator on my first fraction is going to be 1. My denominator on my second fraction is going to be 1. Next, I'm going to look at my other diagonal, 10 and 6. What could I divide both 10 and 6 by? I could divide 10 and 6 both by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So now that I've simplified that a bit, it makes it a little bit easier for me to multiply. So top times top, 1 times 3 is 3. 5 times 1 is 5. And don't forget that negative.